Now we are going to look at the dilation. Obviously, we worked on this one in year 10 class, dilation. First, from away from x-axis. That means basically if we have x comma y, now it is becoming x comma, let's say, k times y. So the y height is k times higher. Either you are going away or towards x-axis. If k is smaller than 1, definitely you are going towards. If k is greater than 1, goes away from the x-axis. K is less than 1 means I meant between 0 and 1, goes towards. In each case, we just pull it. It is dilation from the x-axis, could be either towards or away. Now, when we work that through, the functional formation as we worked out, so y equals k e to the x. So it becomes k times e to the x with a dilation of factor k from the x-axis. Well, let's have a look at an example where my now k value is in color, y equals 3 times e to the x. All right, let's have a look at here the graph itself. Set of axes first. Our normal graph, I'm going to sketch that one in a lighter color. So that will be basically goes through 0, 1. I'm gonna make it a broken line so that it doesn't distract our work here with my solid line for the actual graph, which is 3 times e to the x. Now we are going to sketch 3 times e to the x. You notice the values y height 3 times bigger as it used to be, goes away from the x-axis. However, you notice even though it's 3 times higher, the y equals 0 asymptote stays the same because it is reaching y equals 0 height at the far corner on the left. However, the height becomes higher. So if it is that 3 times higher, and then obviously the graph goes like that, where the intercept is 3 times higher than it should be on a normal graph, which is 1. Could you give me thumbs up on understanding that, everyone? Just going away from the x-axis. Obviously, we can embed what happens. Let's say blue color, y equals half x. Sorry, half e to the x. Half e to the x. That is simply half of e to the x. That is, again, half the values of what you have, and then obviously like that. So the heights are half the height of e to the x. Could you give me thumbs up, everyone, understanding that? Awesome. Keep up. Let's copy all of these now, everyone. It's a dilation. Now it is away from the x-axis. I'll give you a few minutes. Now we are going to have a look at dilation from the y-axis. That is basically, we are looking at, you go away from the y-axis. If I had x comma y, now I'm going to look at, let's say, bxy. That means the height at x is now at bx. So you go away from it. When you make this one to be, okay, see, it is x dash, y dash, a new set of coordinates. You can write down, okay, x dash is bx and y dash is y. We know the relationship here for the y equals e to the x. Hence, we can write down relationship between x and y, but not between x dash and y dash, which we need to figure out. What I can do is I can simply make x the subject here. That gives me x dash on b, and then y the subject there, which is already y dash, and then substitute back in the normal equation where y is y dash, x is x dash on b. Hence, that is again x and y. My equation, if you dilate from the y-axis, it is e to the power x on b. So that is our formation, if that was the case. Let's copy that, everyone, and then we can work on an example. I'll give you a minute to copy. Now we are going to look at an example. In this example, we are going to embed a value here. Let's say y equals e to the x on 3. Or did I use 3 earlier? Let's make it 2. Great. Now what we are looking at is set of axes first, and then understanding what's happening. X on 2, x on b. So it's factor of 2, dilation of factor of 2 away from the y-axis. That means when I had my initial graph e to the x, that's y equals e to the x. Now, my new graph is twice as further from the y-axis. That means if I had a value, let's say at 1, let's make it scaling wise, at 1e, right? Now that value is moved to a point where it is now at 2, it's a, because you are now twice as further away from the y-axis as you were before. Did you all give me 11 methods thumbs up, understanding that? The whole crew, I need you to get a good attention here. What's happening? Well, waiting for a few of you. Awesome. Well done. That means every single point is as twice as further away from the y-axis it was before. For example, at 2, you would have had 2, 2 comma e to the 2. Now, or e squared, let's make it nice and clear. At 2, e to the 2, that is right there. Now it has been moved to twice as further. So right there, that is basically at 4, now it is e to the 2. Obviously, when you put 4 in there, you notice it is 4 on 2, which becomes 2. Right, now what we're going to do is we need to sketch that to the right, but to the left, again, the same thing. Now at, let's say, -1, I had e to the -1, or 1 on e more specifically. That's my height. Now it has moved to the left as twice as it was before, right here. That is at -2, it's 1 on e now. Right, now if I were to sketch it, now you can see the whole graph now dilated away from the x-axis, although it will go through the 0, 1 all the time, because it is just on the y-axis. Now here it is, my y equals e to the x on 2 graph. It goes further away from the y-axis. Could you all give me thumbs up understanding that, everyone? I hope that awesome explanation given you good courage to work on any dilation problem now. So you should be able to handle anything. On that note, let's copy this, and then we will work on number of questions, including up to 3 transformations. Well done, year 11 methods. Keep up. Let's work on all transformations in a minute.